So let's just start with the question first. We are talking about the Euclid's division lemma. So let us suppose we are having the very first question as find the quotient and the remainder Q-r for the following pair. So it is an easy question because we just have to find out the quotient and the remainder. So if suppose we are talking about the very first part, which is nothing but 23 and 4, and the second part is 81 and 3. So let's just start with the very first part. Obviously the number 23 is greater than 4, then we will definitely take 23 as dividend and 4 as a divisor. So let's just start with it. We are taking 4 as a divisor and 23 as a dividend. So let's just start dividing it. We know that 4 into 5 is nothing but 20. 4 into 5 is nothing but 20. So the remainder will be nothing but 3. Obviously we cannot divide furthermore because 3 is less than 4. The remainder r is nothing but less than the number which is over here, which is nothing but b. So we can write it in the formation of the Euclid division lemma as 23 is nothing but is equal to 4 into 5 plus of 3, and this representation is of the type A is equal to BQ plus of R with the condition that R should always lies in between 0 and B. So this condition obviously satisfies over here because this is our Euclid division lemma, and as per our Euclid division lemma, A should always be equal to BQ plus R, where A is nothing but the dividend, B is nothing but the divisor, Q is nothing but the quotient, R is nothing but the remainder, and the value of R should always lies in between 0 and B. So this particular representation is actually following the Euclid division lemma, and we can easily able to recognize what is the quotient and what is the remainder. As we know that the quotient over here is nothing but 5, so the quotient is 5 and the remainder is nothing but 3, and the remainder is nothing but 3. So the very first answer, or we can say the answer of the very first part is nothing but the quotient is 5 and the remainder is 3. So let's just move on further toward the second part. So 81 and 3, obviously 81 is nothing but greater than 3. So 81 will be a dividend, 3 will be a divisor. So let's just divide it. So 3 and 81. Obviously, we know that we have to divide 81 with 3. So let's just start with it. 3 into 2 is nothing but 6. Furthermore, we will get the remainder as nothing but 2. And from the 1, we can carry 1 over here. Then 3 into 7 is nothing but 21. And the remainder is nothing but 0. So obviously the remainder over here is nothing but 0, and remainder is less than the divisor, that is nothing but 3. So this is again following the Euclid division lemma because this can be represented as 81 is equal to 3 into 27 plus remainder, which is nothing but 0, where the remainder obviously 0 is lying in between 0 and B because B is over here is nothing but 3. And from this particular division we can say that the quotient over here is nothing but 27. The quotient is 27 and the remainder is nothing but 0, and the remainder is nothing but 0. So this is all about the Euclid division lemma, or using the Euclid division lemma we can able to find out the quotient and the remainder using this particular division method. I hope this question number 1 is all clear to you.